Now, cosecant and secant are the reciprocals of sine and cosine. And so, although the graphs are not going to end up looking like the sine and cosine graphs, they are directly based off of those sine and cosine graphs. And so our best approach to sketching the graph of either cosecant or secant is to graph sine in the case of cosecant, or cosine in the case of secant, and then build our graph off of that. So in the case of cosecant, it's a reciprocal of sine, so I'm going to graph a sine wave first, and then I'm going to build my cosecant graph. So my sine graph, if we remember from our parent function, it starts at 0, at 2 pi it ends at 0, halfway in between it's at 0, halfway in between the maximum and minimum points it's going to be at 1. So I'll go ahead and count by 1/2 again here. So the second marker, tick mark, will be at 1 and -1. So we're at a maximum at pi over 2, we're at a minimum at 3 pi over 2. And so I'm going to make this kind of a dotted line, because this isn't actually the graph that I'm interested in. I can extend it going backwards as well. Preceding cycle starts at -2 pi and 0. Halfway in between it's going to be at 0. Halfway in between those points it's going to be at its maximum or minimum. So again, a little dotted line here for that sine wave. So for the cosecant graph, remember cosecant is the reciprocal of sine. Well, at all the zeros for sine, the reciprocal of 0 is 1 over 0, which is undefined, which in our experience translates into an asymptote. So that means at every single place where sine has a 0 value, we're going to have an asymptote. So that means that all of these multiples of pi, all these places where the graph crosses through the x-axis, we're going to have an asymptote. And then when I take the reciprocal of a number like 1 or -1, I get that exact value. So at the tops of and bottoms of all of these parts of the sine curve, my graphs are going to meet. My cosecant graph is going to meet my sine graph. The reciprocal of 1 is 1, the reciprocal of -1 is -1, so the graphs are going to be in common there. But then as the sine values get smaller on either side of the peak, let's say right here, the reciprocal of a smaller number is a bigger number. And so as those numbers get closer and closer to 0, when I take the reciprocal of those values, I get larger and larger numbers. So in the end, the result is I get these parabola type shaped curves. Now they're not really parabolas because parabolas don't have asymptotes, but they are these kind of U shapes. And so I'm going to have one at the top there, and then likewise I'm going to have one that's down here underneath the curve on the bottom. And so in this way we can use that original sine wave to help us set up the framework for graphing the cosecant graph. So to be clear, the cosecant graph is that blue graph. It's not the purple one. The purple one is just there to help us provide the framework so that we can find the asymptotes at the zeros of the sine curve, find those maximum and minimum points of those parabola type curves, and then just sketch from there. For secant, we're going to do the same thing. We're going to sketch a cosine graph, and then we're going to use that as the framework to sketch its reciprocal graph, the secant graph. So from our parent graph for the cosine wave, we know that it starts at 1, starts at a maximum. Again, we'll label our x-axis counting by 0.5. So we're at 1 at the second tick mark and -1 at the second tick mark down. So cosine starts at the top, it ends at the top, so that's at 2 pi. Halfway through the cycle, it's at a minimum, so that's going to be at pi. And then halfway in between those maximum and minimum points, the graph is at 0. And so again, I'm going to make that a dotted line here, because that's not the graph that we're interested in. We're just using it as the framework for our actual graph that we want, the secant graph. I'll graph the period going backwards, so -2 pi would be the start of the previous cycle. -pi will be the location of the minimum, with zeros at pi over 2 and -3 pi over 2. And so again, I'll dot in that graph. And so just like we did with the cosecant graph, wherever cosine equals 0, the reciprocal of 0 is undefined. So I'm going to throw in asymptotes at all of the zeros of the cosine graph at all the over 2's. And then I'm going to put in those same right side up and upside down parabola type shapes in between, meeting up with my cosine graph at those maximum and minimum locations. So we can see just on the outer edges of our graph, we're only going to have half of one of those parabolas because we're kind of cut off on each side.